Hey there, U12s. We're looking at exercise 15E. Keep in mind, exercise 15E is not part of the study design, but it is a nice exercise to get your head around understanding some of the key features of it. The first thing is you need to know the difference between more like probability density function, PDF, versus the cumulative density function, okay, or distribution function. And really, in our scenario here, let's just have a look very quickly. In our scenario, it says that between 0 and 1, so 0, 1, you got a graph that is a linear line, so starting at a quarter, so it's 1/4, and it kind of looks something like this. My God, why isn't it drawing the straight line? There we go. So what's interesting is, if I asked you, how do you find the area under the curve, right? The area under the curve represents, again, in a PDF function, it represents the probability. So area equals probability. Okay? And to find that, you would do integration between 0 and 1 of a quarter, because that's the function, dx, and that will give you a quarter x 0 to 1, and then sub 1 in, sub 0 in, so it's a quarter minus 0 on 4, and that gives you a quarter, which we can kind of tell already just saying it's a rectangle there, isn't it? So it's a rectangle, height by width. So we already know this area is 0.25. So what that means is from 0 to 1, cumulatively, the area should be 0.25. Now, how is this different to CDF? CDF, on the other hand, so if you visualize it, here's the difference. One has the area is the probability. CDF wants to represent the probability on the y-axis. So the y-axis is the probability. Okay? The y-axis represents the probability, meaning that when you find, and we usually use capital F of x for CDF, and then we use little f for f of x. Okay, so this is your function, f of x, and the area underneath it, okay, so it means the area underneath it of f of x between a certain interval will give you the probability. True? But we want the function, when we say capital F of x, we want that when you sub in a number for the function, it actually spits out the probability. Meaning that in that example, when x equals to 1, if I sub 1 into the capital F of x, it should equal to 0.25. That's what I'm trying to say. So I'm trying to say when you write f of 1, it should equal to the probability, which is 0.25 in this example, which is very different to saying f of 1 here. Okay, the f of 1 here is actually just talking about the curve, the function, but it doesn't tell you the area. It just tells you the y-coordinate. True? So that's two different things. One is this represents the y value of the function. Okay? Doesn't tell you the probability. The probability is the area under the curve. And then over here, the probability distribution, when x equals 1, then I have the y-axis is 0.25. So this here, when x is 1, and that's 0.25, this represents probability. And at the start, I know both of them are equal at the moment, but as you go through, they're both very different. Because that means when I sub in x equals half, for example, in this case, if I sub in x equals half, can you see that the y value is, I'm just going to rub this one off. When x is half on this side, this would be the y value is a quarter. But over here, when I sub f of half, that is not going to give me a quarter. No, that's not a quarter. It's going to be less than. It should be telling me the probability, which is, I'm going to take off this coloring. It's the probability between 0 and a half. So if you want to know what that is, it should be the integration of 0 to half of a quarter dx. That should tell you the answer. So this would give you what? A quarter x, 0 to half. And that gives you what? Half times a quarter, so 1/8. minus 0 over 4, and that gives you 1/8. So that means 1/8, which is, I think, 0.125, is that right? 0.125, yep, that's correct. So 0.125 is somewhere down here. So 0.125, and there you go. So you see the difference? This coordinate here is when it's half, it tells you the probability, 0.125. But then when it's x equals 1, it's 0.25. Whereas on the PDF version, it's always going to be half a quarter. If you chose a third, it'd be a quarter as well. So 1/3. So they're two very different things. But hopefully you can see something very special. If you haven't noticed, I kind of alluded you to something here. Have you noticed I wrote capital F of x is the probability? Have you noticed how I calculated f of a certain value? I just did the integration of the function. So what are we really saying? The probability, which we said over here before, the area under the curve, so area is the probability, and the probability is f of x. So really, am I not saying this? This is the key fact to take away for the cumulative. So when we ask you to find the function is just the result of finding the antiderivative between a certain interval. So in our case, hopefully that clarifies the theory there and the difference between the two. So if I were to answer this question, the first part of it says find capital F of x, which means find the functions for each interval. So capital F of x should equal to between 0 and 1, less than 1. Okay. What is this? Well, we just said just now the integration of a to b of the curve for the PDF should equal to f of x. So in that case, if you think about the graph, 0 to a certain value, I need the probability to equal to 0.25. But to find that function, right, I know it was just the integration of the actual function. So the first bit is just finding antiderivative 0 to x of a quarter dx. That's it. Okay, why did I put a 0 to x? Because I've got an interval, 0 to 1. I just need it to be a function of x. Yeah? So in this case, we already know that integration of a quarter is just x over 4. Right? And if you sub in 0 to x, that just gives you what? 0x, that's just x and 4. So that means it's a quarter of x. That's the function. Okay? And you can see that when I sub 1 in, so f of 1, that should give me a quarter, which is 0.25. And before, when I said f of half, it was meant to give me 1/8, right? You can see a quarter times half gives 1/8. So it changes. So this is a changing function that represents the area. Okay, so all I'm saying is that if you were to sketch it, a quarter x just looks like this, which is different. Because remember, this represents capital F of x, which is the probability. And how do you find capital F of x? It's just the integration of the curve. That's it. So the next bit, from 1 to 2, okay, so I know that from 1 to 2, okay, I need a curve. Now, there's a bit of a trick here too. So the second bit, you just got to be careful here. Yes, it is just the integration of x cubed on 5, right? So capital F of x is just the integration of x cubed on 5. What you got to be careful though, as you find the integration, can you see that gives you what? x4 on 5 times 4, so on 20, right? The problem is this. If I did it from 1 to 2, is it 1 to 2? Yeah, 1 to 2. Let's see what the area comes out to be. 1 to 2. That gives you 2 to the power of 4. I can't be bothered. I'm just going to use a CAS. Here we go. Whoops. Let's do it again. Why isn't it working? Oh, shift. Shift plus 1 to 2 of x cubed on 5 dx. 3/4. Okay, so This tells me that's 0.75. Now, here's the problem. They're saying in your graph over here, from 1 to 2, the total probability from here to here is 75%. This one was 25% from here to here. The problem is that's starting from 0 to get to 75, right? But we already know that as soon as it hits 1, I'm already at 25. So I can't be starting at 0 and going to 75 again. I actually needed to start at 25, going to a maximum of 1, because 0.25 plus another 0.75 should give me the max probability of 1. So this means that whilst this function was good in the sense that it's x4 on 20, so x4 on 20, the problem is that this is assuming that this was the starting point at 0. So it's not. There is, when you integrate it, technically there is a plus c. Remember that? And because when you integrate there's a plus c, you're trying to find, well, how do I shift the graph so that it makes sure I will start at 0.25 when I sub in the value. Because remember, I want the probability to be a quarter. I just need to know what at when x equals 1, I know that f of 1 needs to equal to a quarter. So I just need to solve for c in this case. So it'll be 1 to the power of 4 over 20 plus c. And what is that? That's 1/20th. So 1 quarter take away 1 on 20 should give you c. 1 quarter take away 1 on 20. Oh yeah, that's true. That was quick, and I should have just figured that out myself. But there we go. So c equals 1/5. What does that mean? That means the curve to represent this next section is x to the power of 4 on 20 plus 1/5. That will guarantee that in the next section, so when I write x to the power of 4 on 20 plus 1/5, that when I write x equals to 1, when I sub in f of 1 in, I should get 0.25. Okay? That's the idea, because I wanted, that's what I did. I literally just solved. If you noticed the way I did it just now, I'm just going to change this. Okay, delete that. So remember, what am I saying? Where for the f of x, I wanted that when x equals 1, the area, so f of 1, capital F of 1, needs to equal to 0.25, meaning the probability is 0.25. How do you find f of x? Well, we knew it's antiderivative of f of x dx. Okay, so with this piece of information, I can then solve for the missing thing. So the function integration of x4 on, what was it again? No, x cubed on 5 dx works out to be, it was x4 on 20 plus c, but then I can sub in this piece of information. So that's meant to equal to 0.25 when x equals to 1. And then I figured out that c was equal to 1/5. So therefore, my function is x4 over 20 plus c. Make sense? Okay, and then so that's the second bit. So I've got the second bit, and then now you go to the third bit. Well, they say, notice that this already all adds up to 1. So from x up until 2, it's already 1. So from 2 onwards, greater than 2, the probability should be 1. And that's probably the only part that you need. I think it's hard to sort of understand to start off with, because one is the area and one is the y-axis. But hopefully the fact that, like, the thing that you take away is this bit here. Yeah? So the y-axis, which is the probability, that is found by finding the antiderivative of the curve. And that's all it is. It's just switching your mindset that you just need to guarantee that 0 to 1, you find the curve, so find the integration, and as long as it still works, so the first one is always easy. It's the second one, you just got to readjust it so that when you antiderive and you sub in these points, it should give you the correct probability. And the next one, obviously, Well, it's 1 because the total probability can only add up to 1. So here's like 0.25. The next one, whatever x4 looks like, so let's just say it kind of looks like this, for example, then it just needs that to add up to a total of 1. So that's probably the only tricky bit. Let me know if you want another explanation to it, but really that's the main difference between the two. So CDF and PDF. PDF is the function, f of x, and the area underneath it, which is the probability, whilst capital F of x, which is CDF, represents the probability on the y-axis. That's all it is. Yeah, and essentially you can take it as that fact there. So the y-axis value is found by integrating the function.